Hi friends, welcome to Krishang Talks. How are you all doing friends? I hope you all are doing great. In today's video, we are going to discuss about the periodic table or the periodic classification. We are going to study about the modern periodic table. There is a modern periodic law which states that the physical and chemical properties of an element are the periodic function of their atomic number. So there are some basics of this periodic table which are these are groups and there are periods. The groups are in the horizontal rows and the columns are the vertical series of columns. So the groups are of elements consisting of similar properties and the periods are of elements consisting of consecutive atomic numbers. So the modern periodic law is a law which according to this law the modern periodic table is constructed, and this law is that the physical and chemical properties of each element is a periodic function of their electronic configuration. So this let's learn about the electronic configuration. The electronic configuration is in which that we can represent in which orbit and in which orbital the electron enters into, and this is using the NLX method. The NLX method is in which the N is the orbit number or the shell and L is the orbital is the type of orbital and X is the number of electrons present in that orbital. So now this is about the electronic configuration. Now let's learn about the classification of these elements into blocks, which are S, P, D and F blocks. And the valence electrons are the electrons in which are in the outermost shell of a given atom. Now in the S block consists of two groups, which are the first group and the second group, and the common electron configuration for the first group is NS1, and N might be any number from 1 to 8. And the second group is NS2 and N might be any number from 1 to 8. And the third group is in the P block, and which the electron enters into the P block. So the third group's common electron configuration is NS2 NP1 and it goes on until NS2 NP6. This group is called the zero group, and in the zero group consists all the inert gas elements in which they are stable and they don't need to form any compounds because they are already stable, except for some gases like xenon and radon. They form compounds with oxygen. Now let's go to the D block elements. The D block elements are the elements they all are of metals. So these properties are that they are hard, they are lustrous, but mercury is an exceptional case because it is a liquid at room temperature, and when you cool it will become a solid. So the common electronic configuration for the whole D block element is N-1 D1 to 10 or NS0 or 2. The F block elements. The F block elements resides in a single group because they all are of the same property and we don't have space to fit it inside the periodic table. So the common electron configuration for this whole block is N-2 F1 to 14, N-1 D1 to 2 and NS1 to 2. So this is about the F block elements. Now let us discuss about the periodic properties of elements. The word periodic means the properties repeat over and over. So the first property is the atomic radius. The atomic radius is the size between the nucleus and the outermost orbit of the specific element. So the atomic radius increases down a group and it decreases when you go rightwards in a period. This is because the number of protons increase and the atomic number increase. So there are some types of radius, which is the metallic radius. The metallic radius involves the transfer of electrons to attain a stable electronic configuration. That means the electronic configuration of the inert gas elements. So this involves the metallic bond, and the metallic bond is 10% more than the atomic radius of that specific element. Now there is also the covalent radius. This covalent radius involves the sharing of one or more electrons. In this, the atomic size of the element is 30% smaller than the average atomic size of the element. Now there is also the van der Waals radius. The van der Waals radius is the radius between two molecules of an element, and we measure the atomic radius of inert gas elements with this van der Waals radius because they don't combine with themselves. Thank you for watching my video. Please like and share to all my videos and also subscribe to my channel. Have a great day. I'll see you in my next video. Bye bye.